In this video, we will learn about the brand new Spring client to consume HTTP REST APIs, which is RestClient in detail right from scratch. Do watch it till the end to grasp a new concept. Spring Framework version 6.1 has introduced a new REST client for consuming HTTP requests. That is, it is an HTTP client similar to its previous REST template and Webflux. REST client is built over REST template and offers Fluent API similar to Web client. Fluent API implies that its methods can be chained one after another to perform a function, such as restclient.build.uri.get, etc. You can learn about REST template by clicking the video link at the top right corner. In this video, we will learn how to use REST client with examples on commonly used HTTP methods such as get, put, post, and delete. RestClient is available in Spring version 6.1. If you head over to Spring Boot dependency, then the latest version is 3.1.4, which brings along Spring version 6.0.12. So, how do we use it? Fortunately, Spring has released a 3.2.0 snapshot release, which contains Spring version 6.1. A snapshot release is one which is released before the official release and is still under active development. For understanding and learning RestClient, you can use it. Note that these versions are at the time of recording this video. It might happen that at the time you are watching it, Spring might have officially released higher version. Now let's understand how to use RestClient by building an application from scratch. Go to Spring Tool Suite, go to its File menu, select New, Other, and search for Spring Starter Project. Click Next. Enter project name, type of build tool to use. We will be using Gradle with Groovy. Packaging will be jar. Language will be Java. Provide a group and artifact name. Enter a description and package. Click Next. Here we will select the required dependencies. For this application, we only need a web dependency. Also, don't forget to select Spring version as 3.2.0 snapshot, else you won't get RestClient. Click Finish. It is now creating the project. The project is ready and it has also created a main class with Spring Boot application annotation. Another way is using Spring Initializer. Open a web browser and go to start.spring.io. Select the type of build tool, language, and version as 3.2.0 snapshot. Fill in all the details such as group, artifact, project name, description, etc. and then click Add Dependencies. Select Web Dependency and click Generate. This will download a zip file which you can directly import into your IDE. There are already many videos to understand how to create a Spring Boot application from scratch. Link of one such video is given at the top right corner. For this application, we will be using a fake REST API JSON placeholder.typicode.com, which has these endpoints exposed corresponding to all HTTP methods such as get, post, put, and delete, and we will be accessing these with the new REST client. Back to the application. Create a new class. To make it a service, annotate it with service annotation. Now let's declare REST client. Define a constructor for this class. Here we will initialize this REST client. A simple way to create a REST client is using its static create method. You can also pass a base URL in create method. Second way is using its builder method followed by base URL, which will accept a string URL followed by a build method. In this statement, this is the Fluent API which I mentioned at the start. It is Fluent since the methods are chained and the syntax simply flows one after another. Providing base URL is optional, but if you provide it, then you will not require to write it again and again in each method. You can simply provide the resource path and it will be appended to this URL. Now let's implement the first method which fetches the list of all posts. Create a new method, fetchPost. The return type of this method will be a string. Call client.get since we want HTTP GET request, followed by the URI method. The URL to fetch all posts in the web service is /post. Provide this URL here, then retrieve method followed by body. Inside body method, we define the class or data type of the variable in which we would like to hold the response. For now, define it as a string. The complete URL that will be accessed by this method is a combination of base URL that we define here, followed by this URL. To check if this method is working fine, let's create a controller and expose an API. Create a new class, annotate it with REST controller. Here we need an instance of service class, so auto-wire it. Define a new method. Its return type will be a string. Return all posts from service method. Annotate this method with getMapping annotation, since this method will serve HTTP GET request along with a URL at which it will be accessible. Start the application. It is started at port 8080. Go to Postman, create a new request. The URL will be localhost:8080/post. This will be a GET request. Send. Look, we got the list of all posts. And if you go to our fake REST API and look at the response of this URL, it is the same as we have got. So, our REST client is working. We can also convert the result of this GET request directly to a list of objects instead of a string. This makes the processing more easier, such as finding a post with a particular ID, title, etc. Suppose we want the response as a list of post objects. For this, first create a new class, name it post. The fields of this class must be the same as the keys in the post in web service, such as user ID, title, and body. Generate getter and setter methods for these fields. Now, change the class type in body method to a list. Change the return type of this method. Also change the return type of controller method. Restart the application. Go to Postman, send. It works. Now let's define another method to fetch a post using its ID with RestClient. Define a new method in service. This method will accept the post ID as argument and return a post object. URL to fetch a single post in our fake web service is /post/ID of post. So, client.get, since this will be a get method followed by URI method with the resource URL as its argument, followed by retrieve and body. Inside body, provide post.class since we will directly map the response to a post object. Assign this to a post object. Now, expose a new API method to return a post by its ID. Return type of this method will be a post object and it will accept an integer argument for post ID. Call corresponding service method and return result. Its mapping will be a get mapping followed by the URL, which will be posts. We will be getting this post ID directly from URL, and for this, introduce a variable inside curly braces. To link this variable with this method argument, use Spring's path variable annotation followed by the name of variable. The name given in path variable and URL mapping must match, and it will populate this method argument with the value provided in the URL. So, when you access URL post/1, this 1 is injected into this method argument. There is a dedicated video on path variable whose link is at the top right corner at the moment. Let's check if it is working. Go to Postman, add a post ID which we have to fetch after the URL. Method will be get only. Send. We got the post having ID 1. Change the post ID to 2. It is working. Now let's see an example of post request with REST client. Create a new method. This will accept the object that we need to post to the server. Now, to send request, use post method of REST client similar to how we used get as client.post.uri. The URI will be /post followed by the content type method. To supply the object that we need to post, use body method, and to fetch the response, use retrieve method again, followed by the body method containing the type of object to which we want the response to be cast. This is similar to get method above. Create a corresponding controller method. This method will accept a post object as argument and will call the corresponding service method we just created. URL mapping for this method will be post mapping followed by the URL at which we want to expose it. Now, the client will send a JSON request, and to auto-populate the fields of this Java object with the values of JSON, we need to provide request body annotation. Go to Postman again, change the method type to post and also change the URL. For sending a post request, we need to send request body, which shall contain the object we want to create in JSON format. Let's copy this, select body, raw and type to JSON. Paste the request body and remove ID from this request since the ID is auto-generated when a new post is created. Send. Look, we got the new post created in response and also the ID is auto-generated. Let's create a method to update a post. Updating a record is an HTTP put request where we send the object to be updated, similar to post request. The only difference between post and put is that post creates a new object on the server, while put updates an existing one. So, the object in create method does not contain an ID, while the object in update method has an ID. That's how we differentiate between a new and existing object. If we go to our web service, this is the URL for put request, where we also need to send the ID of object to be updated. Also, if we look at its implementation, it expects the object to be updated in its body. Back to the service. Update method will be similar to create method. So, copy this, change the name to update post, and change this method to put. Also, we need to send the ID in URL. We can get it from this post object directly. Create the corresponding API method in controller. This will also be a copy of create method except that the HTTP method will be put, and so we need to change this to put mapping. Call the corresponding service method. Start the application. Go to Postman again. Change the method to put. Add an ID with value of 1 since this is the ID that is expected by the URL in our fake web service. Also change the title and description to make it different from new post. Send. It works. Finally, implement delete method in our REST API using RestClient. Delete method expects the ID of post to be deleted and nothing in the body. So, define a new method to delete. This method will accept the ID of post to delete and will not return anything. Then, the same method, RESTClient object followed by delete followed by URI with a URL, and the URL will be /post/ID of the post. Since delete operation in the web service is not returning anything, we need to call toBodylessEntity method. Go to controller and create a new method to delete a post. This method will accept post ID argument. Call the corresponding service method and return a success message. The URL mapping for this will be a delete mapping followed by the URL. Again, we will accept the ID of post from the URL itself using path variable, similar to what we did when fetching a post. Restart the application. Back to Postman. Change the method to delete and provide the post ID in the URL. Delete request does not require a body, so we can set this to none and remove the body. Send. Works fine. So, in this video, we learned about the new REST client introduced in Spring Boot 3.2, how to define it and use it to consume REST APIs, and how to design a complete REST application with HTTP GET, POST, PUT, and DELETE methods. Hope you found it useful. See you in the next one.